This video covers how to calculate integers that satisfy inequalities. Have a think about this question. Before looking at the inequalities, let's think about what the question is asking. If I want the smallest value from this calculation, y has to be as small as possible and x would have to be as large as possible. Because if you was to subtract a large number from another number, the answer would be much smaller. So the smallest integer of y must be 5 and the largest integer of x is 6. The same reasoning can be applied for these expressions. Pause and decide for each expression whether the variables y and x should be larger or smaller. Okay, looking at the first expression, if I made the values equal to 5 and 4, would I increase or decrease x, and would I increase or decrease y to make the overall answer smaller? Okay, let's add these two numbers together to get an answer. Let's start by decreasing x to 4. This will affect the answer by reducing it, as the new answer is now 8. The overall answer is smaller. How about instead of decreasing the x, we increase the y? We increase the y to 6 instead. The overall answer is larger. So both variables must be as small as possible to create the smallest value. So with these inequalities, what's the smallest integers for x and y? Smallest value for x is 11, and the smallest value for y is 6. As a symbol greater than or equal to is used, the smallest answer will therefore be 17. For the second expression, both values must be as large as possible to create the largest value. So for this question, the largest value for x is less than or equal to 10 is 10. And the largest value for y is less than 6 is 5. The final answer is 10 times by 5, which is 50. For the third expression, let's test some numbers and see what happens. Let's make x equal to 10 and y equal to 10. Therefore, x over y, or x divided by y, equals to 1. Let's make the numerator larger. So instead of being 10, we make it 20. 20 over 10 equals to 2. From this, we can see increasing the numerator increases the overall answer. Let's make the numerator smaller instead. So decreasing it to 5. 5 over 10 equals to 0.5. Decreasing the numerator makes the overall answer smaller. Great. Let's see what happens when we apply the same reasoning to the denominator. Let's increase the denominator. So instead of 10, we have 20. 10 over 20 equals to 0.5. Increasing the denominator decreases the overall answer. Let's decrease the denominator. 10 over 5 equals to 2. Decreasing the denominator increases the overall answer. So to create the smallest answer from a fraction, we need the smallest numerator and the largest denominator. So looking at our question, 12 is the smallest integer for x and 2 is the largest integer for y. Therefore, the final answer is 12 over 2, which equals to 6. For the last expression, using what we established with the previous, we want the answer to be as large as possible. So the numerator is as large as possible and the denominator has to be as small as possible. So for this question, the largest integer for x is 10, and the smallest integer for y must be 2. The final answer is 10 divided by 2, or 10 over 2, equals to 5. Have a go at these questions. To summarize, decide whether the values of the variables should be as small as possible or as large as possible. Then use the found values to calculate the integer for the question.